Every night sky we see is filled with stars, but hidden between those luminous points are darker mysteries, planets that drift alone, severed from the warmth of any sun. These worlds spend their long existence roaming the interstellar void, not bound to orbits, not tied to any sunrise or season. Some may be as vast as Jupiter, others as small as Earth, each one a traveller torn from its birthplace and left to drift in silence. The thought of these lonely wanderers is strangely soothing, because while they move endlessly, they remind us that even isolation carries its own quiet story. Tonight, our journey will follow these mysterious worlds. It is humbling to imagine that they might never know consciousness, yet in our imagination we will touch them. I welcome you to the Drowsy Astronaut, where we move slowly through the cosmos, not racing for answers but resting in questions, letting curiosity feel soft in the mind. Feel free to relax, to drift off, or even let this play gently in the background. I will be your steady companion while you rest, work, or simply wander with me across the universe. The journey ahead will take us onto a rogue planet, into the stillness of a world without sunrise, and together we will begin quietly, without haste. Rogue planets are born in violent encounters when gravitational forces fling smaller worlds outward, tearing them from the embrace of their parent stars. The process leaves behind systems reshaped with suns continuing their orbits, while scattered planets drift outward into the dark of interstellar space. Each wandering body carries a history, a record of collisions, migrations, and lost stability that eventually doomed it to solitude. The cosmos becomes their only orbit, infinite and empty, but strangely complete in its silence. Scientists now suspect that rogue planets may outnumber stars, suggesting the galaxy could be richer in wanderers than shining suns. The idea unsettles us because we associate worlds so deeply with the comforting glow of a nearby star. Yet the calculations of planetary formation and instability strongly support their abundance, showing how often systems eject their smaller members. The result is staggering: billions of unseen worlds hiding in the quiet between galaxies and stars. Living on such a planet would challenge every assumption we hold about what makes a world habitable. The surface would freeze quickly, oceans locked beneath sheets of ice, and air itself collapsing into frost across lifeless stone. Without a star, there would be no winds, no seasons, and no rhythm of daylight to guide or comfort its surface. The silence would be overwhelming, deeper and colder than anything we have ever experienced on Earth. Still, warmth can survive within these worlds drawn from radioactive decay and the persistence of geothermal energy deep within their cores. The possibility emerges that beneath thick ice, subsurface oceans could remain liquid, shielded from the vacuum above by kilometers of frozen insulation. Here, life could find a niche, thriving in water warmed by venting heat, never needing the direct rays of a sun. The lesson is profound. Sunlight is not the only pathway for life to flourish. Extremophiles on Earth already prove this truth, surviving in vents, frozen glaciers, acidic waters, and radioactive waste. These organisms endure without light, taking energy instead from chemistry and heat at the edges of possibility. If life thrives in such places on Earth, then why not within the oceans of a rogue planet? The parallel is striking, and it expands our understanding of where life could persist beyond our expectations. Imagine yourself standing on such a surface, frozen and barren, the sky an unbroken canvas of unblinking stars. The galaxies would shine sharply, their countless clusters more vivid than anything visible from Earth's hazy skies. Every faint cloud of starlight, every distant spiral would reveal itself, stretching across a darkness unbroken by sunrise. The beauty would be haunting, sharp, eternal, and impossibly quiet. Time itself would lose meaning without daylight to divide it into hours or seasons. The concept of days and months would dissolve quickly, replaced by mechanical clocks or human invention. Civilizations formed here would define time differently, tying meaning to shifts of work, machines, or biological need. The flow of such existence would feel dreamlike, circular, and detached from familiar cycles. Civilizations surviving here would live below the ice, seeking heat from vents, building habitats to replace skies with technology. The structures would resemble endless stations, sprawling communities, where warmth and pressure are carefully maintained. Energy would flow from nuclear sources or geothermal power, sustaining crops, shelters, and delicate life. The vision of such survival is harsh, but not impossible. Already humanity toys with the technology needed for it. Moons could still orbit these lonely planets, held in place, even as the system drifts free. Their disks would reflect faint starlight, moving slowly across the black skies, without the glow of a sun. Every orbit would continue, gravity binding companions, even without the anchor of a larger system. The sight of moons circling a dark planet would feel surreal, delicate ornaments drifting across endless velvet. Even the air of such worlds could behave differently. A thick atmosphere of hydrogen or methane might trap heat, keeping hidden oceans liquid for billions of years. Such protection would create potential for deep habitats, shielding biology beneath the ice. The physics tells us clearly, habitability is not confined to the presence of starlight. Explorers who imagined this surface would notice silence first, an absence of wind, rustling, or familiar sound. The landscape would answer with only cracks of ice or the echo of their own movement. Every breath, every hiss of air, every mechanical pulse would stand out against that cosmic emptiness. The feeling would be profound, both lonely and intimate at once. Emotionally, living here would transform the mind, reshaping rhythms deeply tied to daylight. Without sunlight, depression and disorientation could easily follow, severing the anchors of memory. Artificial light and engineered cycles would be required to replace what the natural sky no longer gives. The cost would be heavy, but humanity adapts, and adaptation is survival. Even lifeless rogue planets are treasures for science. Their cores preserve early records, frozen histories of collisions and migrations. Studying them would reveal the evolution of systems, showing how instability creates wandering orphans. The knowledge would enrich us, exile carrying lessons in its silence. Telescopes search for them now, detecting faint infrared signatures left by heat leaking from within. Through microlensing, their passing gravity bends starlight briefly, betraying their otherwise invisible presence. Occasionally, we confirm their existence, one shadowed glimpse at a time. The truth builds slowly, the universe is full of unseen wanderers. Future explorers may reach one sending probes across dark space to sample its crust, its core, its frozen secrets. Such missions would redefine habitable, forcing us to reconsider where life may exist in the galaxy. Perhaps beneath such ice, civilizations already wait, unlit, unseen, but surviving. The thought lingers with us, thrilling, haunting, and humbling at once. Beneath the frozen shell of these wandering worlds, immense hidden oceans could stretch for thousands of kilometers, sealed away and warmed slowly by inner heat. The darkness in such oceans would be endless, interrupted only by the faint glows of geothermal vents, rising from fractured crust. Every plume of minerals, every shifting stream of heated water could provide the chemistry that allows life to take shape and endure. The lesson becomes clear: warmth does not always need a star, for sometimes it rises quietly from the heart of a planet. Here on Earth, hydrothermal vents already demonstrate this same astonishing principle, offering whole ecosystems independent of the sun's direct light. The creatures clustered there feed not on sunshine, but on energy, harvested from sulfur, methane, and other minerals released from beneath. Bacteria thrive first, converting raw chemistry into usable forms, before supporting entire webs of worms, crabs, and strange translucent fish. The parallel with rogue oceans is powerful, reminding us that hidden seas may harbor life in the same resilient way. Still, these oceans would remain locked far under thick ice, never sharing their secrets with the stars above. The surface would be cold, barren, and utterly lifeless, even as activity continued in dark seas below. Civilizations, if they ever arose there, would never see constellations, never know day or night, only liquid water and stone. The perspective is humbling, suggesting that life may be common, but often hidden where our eyes cannot look. Imagine the pressure inside those hidden oceans, the crushing weight of ice kilometers thick, resting above liquid water. The seas would dwarf Earth's, stretching deeper than any trench we have ever explored with machines or submarines. Creatures there would evolve without need for eyes, guided instead by vibrations, chemicals, and subtle flows of current. The feeling of such a place would be alien but not outside the boundaries of what we already understand. Humans attempting to survive here would require new technologies designed to float or anchor in dark seas of unimaginable pressure. The habitats might cluster near volcanic vents, drawing energy from heat sources, or deploying portable nuclear reactors for survival. Communities would exist without skies, replacing every horizon, with walls of ice and ceilings of steel. The concept is extreme, yet within reach of imagination, especially as our species already plans for survival beyond Earth. Above these oceans lies the icy crust, an environment even more hostile to unprotected life than the waters beneath. The surface would remain frozen harder than Antarctica's glaciers. Winds absent because no sunlight stirs air across that frozen expanse. Without starlight, the only glow would be galaxies shimmering above, offering light without warmth, clarity without comfort. The solitude of such a place would be overwhelming, each step echoing across plains unchanged for millions of years. Moons could still orbit such wandering planets, moving in predictable arcs though the system drifts endlessly through space. Their disks would appear faint against black, reflecting meager starlight that makes no difference to the frozen surface. Every orbit would continue, gravity binding companions in a silent dance, even without a central sun. The sight of moons crossing alien skies would be surreal, haunting markers of time in a place without days. Cultures born on rogue planets would shape themselves without reliance on sunlight. The myths they told would not involve constellations or seasons, but instead the glowing plumes of geothermal vents. Instead of stories about dawn, they might speak of deep currents, shifting ice and mysterious movements below. The symbols of life would come from within, not from above. Even their timekeeping would drift, with no rotation to divide one day from the next. The concept of years, months, or weeks would vanish, replaced by artificial systems built by necessity. Every society would rely on machines to regulate schedules, anchoring sleep, work, and rest. The experience would be dreamlike, endless streams of time, without natural divisions. Imagine the psychological toll of never seeing sunlight, of never knowing the warmth of a day's end. The loss of natural cues already brings depression to humans in polar winters when darkness lingers too long. Here, such conditions would be permanent, requiring careful engineering of artificial lights and social rhythms. The survival of minds would be as critical as survival of bodies, because time itself becomes unsteady. Still, one consolation would remain: the galaxy above, displayed with unparalleled brilliance. The Milky Way would spread across the sky, its arms sharp and luminous in frozen stillness. Every faint cluster of galaxies would reveal itself clearly, each one a billion stars glowing far beyond. The sight alone could anchor memory, beauty offering meaning when warmth cannot. Technology would provide pathways to survive, though the effort would be vast and unrelenting. Domes heated by reactors, farms beneath artificial lamps, and habitats buried in ice would define life. Yet humanity has already tested many concepts for living in extreme isolation, from submarines to polar stations. The vision is difficult, but not beyond the reach of human ingenuity. Scientists now suggest that rogue planets may be havens, supporting oceans for billions of years without suns. The logic follows. Geothermal heat sustains, while ice insulates and protects against the cold vacuum above. Thus, these planets could be more common homes for life than the bright star systems we focus on. The implication is staggering. The galaxy could be teeming with life we cannot yet detect. Detection is challenging since rogue planets remain nearly invisible to our telescopes. Their heat fades slowly, detectable only in faint infrared signatures. Occasionally, they betray themselves through microlensing, gravity bending light from distant stars when alignment is perfect. The evidence grows steadily, though each discovery is fleeting. Proof accumulates that the darkness is crowded with wanderers. Perhaps, beneath their ice, whole civilizations already thrive, unnoticed, hidden from stars, never knowing night or day. The possibility unsettles yet expands our vision, suggesting life might not require sunlight at all. Life may prefer stability, choosing oceans insulated beneath crusts instead of fragile surfaces bound to stars. The cosmos leaves room for these thoughts, and it changes what we believe is possible. Even sterile rogue planets remain invaluable archives in the story of cosmic formation. They preserve ancient matter, records of collisions, migrations, and cosmic violence stretching back to formation. Studying them reveals how systems collapse, scattering orphans into interstellar dark. The knowledge enriches us, exile becoming its own kind of story. Future probes may one day reach them, sampling crusts, drilling ice and peering into their depths. The missions would stretch decades, but their value could be transformative. Every success would teach us about habitability, showing us that life is broader than starlight alone. The hope endures, curiosity drawing us further outward into infinity. Meanwhile, we sit here, picturing those frozen oceans and their timeless silence. The images we create show that science is more than answers. It is imagination stretched wide. Every thought of these planets is a quiet meditation on survival, solitude, and resilience. The lesson they carry remains simple. Emptiness does not equal absence, and silence does not equal lifelessness. Imagine stepping slowly onto the frozen crust of such a planet, your boots pressing against layers of ancient ice that stretch endlessly in every direction. The air is thin and still, carrying no warmth, no winds, only the faint creak of surfaces contracting in the cold. Above you, the galaxy appears sharper than ever, billions of stars piercing the black, with clarity so pure it feels unreal. The silence is absolute, and your own heartbeat becomes the loudest rhythm in this infinite and frozen wilderness. Every breath you release fogs instantly, curling into crystals that drift before vanishing in the unbroken dark. The temperature presses down, so low it feels less like cold and more like absence, as though warmth never existed here. Each step sinks slightly into powdery frost, the crunch echoing outward, carrying farther than seems possible in the still air. The feeling is otherworldly, as if time itself hesitates while you wander across landscapes untouched by anything living. Look up again and notice the faint arcs of orbiting moons, companions circling quietly without offering light or seasons. The motion of these moons is slow, their paths unbroken reminders that gravity binds them still, even without a star. Every orbit is a clock ticking across centuries, marking cycles in a world that otherwise has no natural rhythm. The awareness of this deepens your solitude, as if you alone are measuring time with them while the galaxy continues unaware. Now pause and kneel to touch the surface, your glove pressing against the ice, layered thicker than any mountain on Earth. The texture feels both solid and fragile, a crust covering what might be entire oceans, hidden and waiting in silence. Beneath your hand could lie an ocean deeper than any sea, stretching for thousands of kilometers below this frozen shield. The idea takes root that life might linger under your touch, unknown, invisible, and yet completely possible. Close your eyes for a moment and let the darkness itself become part of the imagination, as though the planet surrounds you entirely. The absence of sound makes your breathing louder, reminding you that here, in this moment, you are the only source of motion. Slowly, the lack of sunlight forces you to sense differently, guided by texture, by temperature, by the faint pull of gravity. The experience is hypnotic, isolation becoming not emptiness, but a slow meditation on presence. Picture yourself walking across frozen plains, the ground stretching without end, every direction repeating the same endless pattern of frost and starlight. The light of distant galaxies is cold, offering no warmth, only clarity, as though the universe wants you to see forever. Every shadow is sharp, drawn in black against white. The contrast so clear it feels etched into your mind permanently. The landscape is stark, but the more you walk, the more its silence begins to soothe instead of frighten. Imagine if you stood still long enough to truly feel time here, not in hours or minutes, but in vast and patient stretches. The cycles of your body become the only measure. Your heartbeat, your breaths, the rhythm of your own steps. Without sunrise or sunset, time loses edges, blending into something circular, as though it can never truly begin or end. The effect is mesmerizing, each moment dissolving slowly into the next until awareness itself softens. Think now of what it would mean to build a home in such an alien silence. The structures would be buried under ice, sealed against cold, powered by reactors, insulated to preserve fragile warmth. Inside, light would come from lamps, creating cycles that pretend to be day and night, artificial rhythms to guide memory. The contrast would be immense. Artificial light against infinite dark, human life clinging inside a shell within a frozen void. Picture leaving that home, stepping back into the night. Your helmet filled with recycled air, your suit heavy but protective. The galaxy above watches, its billions of stars staring like unblinking eyes, stretching across the heavens with relentless clarity. Every sound is internal, your own breathing, the faint hiss of systems keeping you alive, reminders of fragility. The moment presses deeply, a reminder that your presence here is both impossible and profoundly human. Now, imagine digging deeper, building tunnels through the ice, searching for the ocean below that whispers possibilities. The journey would be slow, with each layer resisting but eventually yielding, as you descend through ages frozen in silence. Finally, water would rush upward, an ocean untouched for billions of years, carrying mysteries no sunlight ever revealed. The feeling would be breathtaking, as though you had reached the heart of a secret world hidden since time began. Close your eyes again and place yourself not above, but within that ocean, floating weightless in the darkness. The pressure surrounds you, heavier than anything felt on Earth, but the silence is calming, absolute in its stillness. Every vibration tells you something, the faint movements of unseen creatures, the flow of currents rising from geothermal vents. The realization sinks in that this is not emptiness, but a hidden environment where life could quietly persist. Here, extremophiles could thrive, bacteria feeding on minerals instead of sunlight, weaving whole ecosystems together. The web of life would look different, built without plants, without photosynthesis, without familiar rhythms. Yet, every organism would still adapt, using what it has, transforming chemical gradients into survival. The beauty of this thought is gentle, that life does not require familiarity to endure. Imagine a civilization born here, never seeing stars, never learning constellations, never marking seasons. The culture would shape itself around depths, its myths describing currents, vents, and the unseen shapes of creatures. Knowledge would be measured in flows of chemistry, in survival against darkness, not in astronomy or daylight. The perspective is remarkable, because meaning could evolve entirely separate from light. Now, climb back into the imagination of yourself above ice, standing once more beneath the cosmos. The clarity of the sky overwhelms you, every galaxy sharp, every star distinct, no haze to blur the view. Every gaze upward feels like looking into eternity, your eyes drinking in more than Earth's skies ever revealed. The experience is profound, the galaxy becoming a substitute for daylight. Picture resting here, lying back against the ice, your body still, your vision filled with countless points of light. The temperature seeps through, numbing your senses. But instead of fear, there is calm in the endless stillness. Every sound is gone except the rhythm of breath, steady, measured, echoing faintly against your own awareness. The silence itself begins to cradle you, as though the planet is rocking you into sleep. Think of how slowly you would age here, your biology unanchored from normal rhythms. The absence of day and night alters perception, stretching every hour into something fluid. Life feels untethered, floating in continuity that ignores familiar clocks. The effect on consciousness is dreamlike, as though time itself has been softened. Imagine staying here long enough that the world no longer feels alien. The patterns of your body adjust, memory adapts, and new rhythms emerge. Eventually, this place becomes its own home, not an exile, but a normal state of being. The truth becomes visible. Even isolation can feel like belonging. Meanwhile, the galaxy continues around you, the great currents of stars, moving on scales you cannot perceive. The knowledge that you are so small yet so present adds depth to every thought. Every glimmer of starlight carries its own story. Suns with planets, perhaps other civilizations dreaming their own nights. The awareness of this deepens the calm, reminding you that you are part of something unbroken. Imagine waking inside a habitat buried beneath layers of protective ice, the faint hum of machines surrounding you, with steady reassurance in the silence. The air is carefully recycled, warmed just enough for comfort, its taste metallic yet familiar after years of technological dependence. Artificial lamps glow softly, simulating dawn, their light reminding your body of rhythms that the planet itself no longer provides. The routine begins slowly, rising from rest not because of sunrise, but because cycles demand structure for survival. Step into the main corridor, where others move quietly, their voices low, as though respecting the darkness outside even here. The hallways are lined with frost-sealed walls, keeping the cold beyond from seeping inward, every seam carefully maintained. Every person carries responsibility, whether tending systems, preparing food, or monitoring pressure gauges that preserve fragile life. The feeling is communal. Survival binding everyone tightly, dependence on one another replacing sunlight as the measure of safety. Meals are grown in hydroponic farms, long rows of glowing plants rising beneath LED lamps that simulate the missing sun. The greens smell fresh despite their synthetic origin, offering both nutrition and psychological comfort in the endless dark. Eating together becomes a ritual, a chance to share stories that preserve memory, to laugh lightly, to silence isolation. The rituals of daily life matter here, small anchors holding identity steady in a drifting world. After meals, tasks resume, repairing filters, checking geothermal taps, or maintaining the reactors that keep the habitat alive. The systems are lifelines, and every failure would bring disaster. So diligence becomes habit, patience becomes instinct. Children born here grow up learning about machines first, before stars or oceans, their education shaped by necessity. The knowledge of survival itself is culture, built around ice, metal, and human effort. Outside, expeditions still occur, though rare, when resources must be gathered or surfaces studied. The suits are heavy, layered to protect from radiation, cold, and the pressure of an alien world. Every step on the frozen plains becomes a meditation, with silence pressing, as heavily as the gravity itself. The awareness that no mistake is allowed keeps each journey careful, deliberate, and slow. Return to the habitat, and the relief is palpable, warmth rushing back, as the airlocks close and pressure stabilizes. The contrast between outside and inside reminds you why humans cannot yet claim this world without machines. Every opening of a door is a reminder of fragility, a thread between life and void. The gratitude for technology is deep, for without it, the world would erase you instantly. Imagine generations passing here, children never seeing stars directly, only through windows or filtered helmets. The galaxy above becomes myth, a sky that exists only as a concept, not as an everyday reality. Stories of Earth are told, with sunrise and warmth described as something almost magical, cherished like memory. The idea of a sky filled with color becomes a legend, shaping identity as deeply as history once did. Culture adapts accordingly, shaping myths around vents, around ice, around the glowing farms that sustain life. The symbols of survival are no longer trees or rivers, but pumps, filters, and glowing machines. Even time is marked differently, measured in cycles of power generation, in the steady rhythm of reactors. The calendar is no longer tied to stars, it is tied to survival. Think of the music that might be created here, built from echoes, low tones, and steady beats. The instruments would be metallic, resonant with the vibration of enclosed halls. Songs would reflect the environment, repeating like machines, calming minds as they fall asleep within metal walls. The soundscape of culture would be unique, an echo of life in exile. Imagine rituals for comfort like painting glowing patterns on walls, simulating constellations, or the shapes of moons. The symbols offer memory, reminding people of what sky once meant to ancestors. Children trace them with hands, learning about galaxies not by seeing, but by stories and images. The imagination carries weight, filling the gaps left by absent sunlight. Even education shifts to survival, teaching young ones the chemistry of water, the physics of heat, the balance of recycled air. The concepts are practical, grounded in necessity, because every person must know how to preserve life. Knowledge becomes a shared treasure, passed carefully between generations, as the foundation of culture. The act of teaching becomes sacred, each lesson a reinforcement of resilience. Picture resting at the end of such a day, the habitat dimming into artificial night, lights lowering to help minds reset. The stillness of the planet outside creeps inward, its silence resonating faintly, even within metal walls. Lying down, you close your eyes, imagining oceans beneath ice, creatures drifting unseen while you dream above. The boundary between imagination and reality blurs, and sleep feels as endless as the night. Meanwhile, outside the habitat, the planet continues to drift across the galaxy, unseen and mostly unknown. The motion is constant but imperceptible, its path carrying it farther from the place it once belonged. Every kilometer is gained in silence, every moment a reminder of exile and distance. The journey of the world itself is patient, a cosmic wandering without destination. Consider now how such a life shapes the human soul, stretched across years without sunlight. The emotions may shift, with longing for skies mixing with gratitude for safety. Some may adapt fully, finding comfort in the steady rhythms of machines. The psychology of survival changes slowly as isolation becomes familiar instead of frightening. Even art takes new forms, expressed through patterns of ice, reflections of lamps, or movements within enclosed halls. The creativity does not fade, it transforms, shaped by the environment's harsh rules. Every creation reflects endurance, the blending of technology and human imagination. The expression becomes survival itself, and survival becomes art. Imagine stepping out once more, this time to simply look at the galaxy. In its unbroken brilliance, the sight stretches forever, countless stars, each with their own systems, their own stories of creation. Every glimmer reminds you that life might exist elsewhere, hidden like yours, patient and unseen. The thought is humbling, a reminder that solitude is never truly empty. Still, the rogue planet's surface remains mostly unchanged, frozen in quiet endurance, unmoving and severe. The landscapes are marked by craters and faults, the scars of collisions from ejection long ago. Nothing shifts quickly, for without a sun, weather no longer sculpts or reshapes the surface. The world becomes timeless, a monument to stillness. Eventually, if explorers from Earth ever arrive, they would step onto this crust and see what you imagine now. The records they gather would tell the story of violent beginnings, of exile, of hidden potential. Perhaps they would find subsurface oceans, confirming life beyond stars and widening our search. The possibility would change everything, expanding the boundaries of where we search. Now it's time to imagine being born here, beneath layers of protective ice, your first memories shaped not by sunlight, but by artificial lamps. The air you breathe is metallic and recycled, yet it is the only atmosphere you will ever know as natural. Every wall surrounding you hums with machines, their sounds so constant they become background music, like wind once was for Earth. The truth of your world is clear. There is no sky, no dawn, only cycles marked by human invention. Children raised in such an environment form associations that differ completely from ours, attaching comfort not to nature but to systems. The warmth they feel is the glow of lamps, the steady reliability of pipes, heaters, and humming vents. Games involve exploring tunnels or tracing luminous symbols painted to imitate constellations that no eye has truly seen. The sky they imagine is drawn entirely from stories, visions described by parents who carry memory from Earth. Generations grow up learning history through narratives where sunlight is remembered as something mythical, a kind of glowing ocean that once bathed worlds. The idea of warmth becomes cultural rather than physical, carried through language, songs and stories told before bed. Instead of running under daylight, children run beneath domes of artificial light, their laughter echoing through enclosed spaces. the sound fills the silence, replacing what is missing outside. Even the concept of stars feels abstract, told through images displayed on screens, or carved into walls as faint patterns. The stories say they are countless, each one burning, each one a sun like the one their world lost. Children memorize their names, tracing constellations, without ever having seen them directly. The connection is fragile, a memory passed down without proof. Culture begins to form in this darkness, rooted in cycles of work, meals, and maintenance. The celebrations center not on seasons, but on moments when systems last longer than expected or harvests thrive under lights. Songs are sung about vents, about glowing plants, about the safety of enclosed warmth. The themes are practical, survival elevated into ritual. Imagine what dreams feel like in such a world, shaped by sounds of machinery, by the rhythm of lamps turning on and off. The subconscious fills the silence with visions of oceans beneath ice or galaxies above. Every dream stretches longer, untethered from natural cycles of day and night. The mind compensates, creating its own skylines while the body sleeps. Emotions in this environment change across time, shifting with each new generation in ways unfamiliar to us. The firstborn here may feel loss, a longing for something they never truly saw. Later generations may not feel longing at all, but instead quiet acceptance of their strange inheritance. The feeling of exile transforms slowly, isolation becoming identity. Memory itself changes, recorded through stories and preserved carefully, because there are no skies to reinforce them. The elders speak of Earth's sun, describing warmth in words that feel more like myths than reality. Young listeners accept these tales with awe, imagining landscapes that seem as distant as fairy tales. The past becomes a dream, while the present defines itself in coldness and endurance. Identity in such a culture would tie directly to survival and community, leaving little room for solitude. The individual becomes less important than the group, because no one endures here alone. Every child learns quickly that tasks must be shared, that cooperation is not optional but essential. The lesson is ingrained. Belonging is survival itself. Imagine being a teenager here, feeling restless within walls that define your entire world, longing for something beyond. The urge for freedom rises, but outside is death, silent, frozen, and absolute. Rebellion is muted, redirected toward exploration of tunnels or deeper dives into artificial oceans. The boundaries of possibility remain fixed, though the imagination keeps pressing against them. Even art evolves differently, carved into ice walls or drawn in glowing pigments that simulate lost stars. The mediums shift, but expression persists, because the human mind will always find ways to shape meaning. Every image is simple: a tree, a star, a sun, things no one has touched. The desire to create fills the gap, proving imagination is more resilient than absence. Generations born here would learn to accept silence as part of existence. The absence of natural sound means even whispers or footsteps carry weight, shaping every interaction. Children grow up treating quiet as sacred, speaking softly, hearing meaning in every tone. The environment itself teaches them silence is not emptiness, but a form of presence. Imagine standing at a viewing port, looking outward through reinforced glass, at the sharp brilliance of the galaxy. The stars blaze brighter than on Earth, the Milky Way painted in impossible clarity. Every young person here eventually confronts that sky, realizing it belongs to them too. The feeling is overwhelming, a gift in place of sunrise. Children raised in dark oceans would feel differently still, never seeing stars, never stepping outside, knowing only liquid and stone. The currents would be their winds, vents their fires, bioluminescent creatures their constellations. Entire cultures could form beneath these oceans, myths shaped by glowing life instead of stars. The perspective would be alien, yet still deeply human. Even language itself would evolve differently, shaped by environments that never knew day or night. The words for time would shift, describing cycles of machines, flows of currents, pulses of reactors. Concepts of morning or evening might fade entirely, replaced by terms we cannot yet imagine. The language would embody the world, a mirror of timeless dark. Imagine love in such a place, fragile yet powerful, blooming in tunnels or shared meals beneath artificial lamps. The connection feels stronger because life depends on cooperation, and intimacy becomes part of survival. Every gesture of care carries weight, for in exile, comfort is scarce and precious. The bond becomes unbreakable, woven into survival itself. Children eventually become parents, teaching the same stories of Earth's skies, the legends of light. The chain of memory continues, binding generations through words, when direct experience is impossible. Each retelling shifts, imagination coloring details, expanding gaps left by lost context. The heritage endures, proving that identity is preserved even when skies are not. Imagine, centuries later, a society fully adapted to rogue planet life, no longer longing for sunlight. The culture thrives on what it has, building myths around vents, oceans, and frozen landscapes. Generations feel pride in their endurance, in their ability to carve meaning from exile. The story of humanity continues, even here, far from stars. Even in dreams, people would carry their environment with them into the silence of sleep. The silence and cold would shape the landscapes of their subconscious. Sleep would feel heavier, slower, more circular, matching the timelessness of their world. The rest itself becomes cosmic, as though the planet's patience seeps into the body. Philosophy often begins with questions about place, about belonging, about what it means to stand beneath a sky and call it home. The people of a rogue planet would face that question differently, never seeing sunrise or seasons, never tied to rhythms beyond themselves. Here, meaning must grow inward, built not from cycles of stars, but from the machinery and oceans that quietly sustain life. The truth of existence becomes immediate. Life is fragile, survival is profound, and belonging is defined by endurance. Imagine asking a child what the universe means when they have never seen a real sun. The answer would come not in terms of light, but in the comfort of warmth, food, and family. Every definition of existence shifts as the absence of stars changes, how the mind frames its own place. The meaning of cosmos itself bends toward what is lived and felt instead of what is seen. Even today, scientists debate whether life is common or rare, whether we are alone or surrounded by billions of unseen neighbors. The presence of rogue planets suggests that countless hidden worlds may harbor possibilities beyond our sight. Some may hold nothing but ice, yet others may shelter deep oceans rich with potential. The implication is vast, that life may not need sunlight at all, only persistence. Think of how such worlds redefine our sense of what is possible. The habitable zone is no longer about distance from a star, but about insulation, chemistry, and time. Every rogue planet reminds us that boundaries are often human inventions, and the universe itself is less restrictive. The lesson is gentle. Life is flexible, and survival is wider than we imagined. Imagine cultures living in this endless night, shaping philosophy around endurance instead of progress, silence instead of noise. The concept of achievement shifts, no longer measured by expansion, but by the careful preservation of what is held. Every success is survival, every failure, a lesson in patience and repair. The measure of greatness becomes continuity, to endure one more cycle, one more generation. Even art here would become philosophy, expressions of silence carved into walls or echoed through tones. The absence of stars might be replaced with glowing symbols of vents, oceans, and imagined suns. Every piece carries meaning beyond itself, a philosophy of survival turned into creation. The act of making art becomes reflection, proof that meaning persists even in exile. Consider how spirituality may take shape in such conditions, where no heavens rise above and no sun divides day from night. The sacred might dwell in heat vents, in the chemistry that turns stone into energy, water into possibility. Faith could revolve around continuity, the belief that endurance itself is holy. The divine becomes survival, and survival becomes communion. Even the smallest rituals would carry immense weight, whether planting seeds in artificial light or maintaining a reactor's pulse. The task is not just survival, but a reminder of responsibility shared by every person alive. Every moment of maintenance becomes a kind of prayer, a devotion to life itself. The act of working sustains meaning, because without it, nothing continues. Imagine generations passing, each one adapting to darkness, until the memory of sunlight fades completely. The children would hear stories of Earth as though it were a dream, barely believable. Eventually, the myths of sunlight may become symbolic, lessons of warmth told like parables. The connection to stars weakens, while the bond to the rogue planet strengthens. Think of how identity evolves when exile itself becomes normal. The people of such a world no longer see themselves as missing something, but as complete in their adaptation. Every generation grows proud of their endurance, their capacity to thrive where others could not. The philosophy becomes confidence, that survival itself is nobility. Even loneliness transforms here into something both soothing and profound. The silence becomes a kind of companion, wrapping life in patience and calm. Isolation no longer means absence, but instead becomes presence, the recognition of self in a larger stillness. The lesson is simple. Solitude can carry meaning without emptiness. Imagine if explorers arrived centuries later, meeting such a culture, shaped entirely by darkness. The differences would be profound. Philosophies built not on stars, but on survival. Every interaction would reflect contrast, our earth-born myths of sunlight meeting their ocean-born philosophies. The dialogue would reveal much, about how environment sculpts thought itself. Even our own reflection changes as we consider rogue planets more deeply. The knowledge that countless hidden worlds may exist unsettles, yet it also inspires. Every discovery stretches our sense of place, reminding us that exile is more common than comfort. The cosmos reminds us we are all wanderers, even with a star. Imagine sitting quietly, picturing yourself as one of those wanderers. Your home, drifting unseen across endless void. The awareness of fragility blends with the comfort of resilience, a balance only such places can teach. Every thought of exile becomes a meditation on belonging. The feeling is grounding, a strange peace in the unmoored. Philosophy tells us that meaning is chosen, not given, and here that choice is sharpest. The residents of a rogue world must invent their own symbols, their own calendars, their own reasons to endure. Every system becomes meaning, every pattern, a marker of life continuing. The act of endurance is philosophy itself, an answer without words. Science grows slowly in such exile, shaped by necessity first, but eventually curiosity begins to press against the limits of survival. The people of a rogue planet might invent tools not only for repair, but for questions about their place in the cosmos. Every observation they make, from shifts in gravity to faint glimmers in the sky, becomes part of a long, patient learning. The act of survival turns toward exploration, because to endure is not enough. One must also understand. Imagine the first instruments they create, fragile telescopes pressed against sealed domes, searching for patterns in endless dark. The sky they study is sharper than ours, filled with stars that blaze unbroken by atmosphere, crisp and eternal. Every dot becomes a possible destination, a potential neighbor, a silent reminder that their planet drifts among countless others. The questions deepen. What is distance? What is motion? And what does it mean to be unmoored? Knowledge grows slowly but surely, passed carefully across generations, shaping culture with its steady rhythm. The elders may teach how to recognize galaxies, spirals of light faint but constant, as symbols of orientation. Children would mark these patterns, connecting memory to stars never seen by their ancestors. The act of naming becomes powerful, because naming gives order to the unknown. Even mathematics evolves differently here, tied to cycles of machines, to orbits of moons, to slow drifts of planets. The concept of measurement itself may grow from watching shadows of satellites pass against starlight. Every calculation reflects their environment, practical yet tied always to the grander picture above. The numbers gain weight, a language that bridges survival and imagination. Consider the experiments they might attempt, drilling deep into ice, to test chemistry, pressure, and the potential for life. The oceans beneath remain their greatest mystery, hiding possible creatures that shape myths as much as science. Every probe they send deeper teaches them resilience, not only of materials but of will itself. The results build slowly, truth emerging not from speed but from persistence. Imagine the moment they detect movement in those seas, life where only silence had been assumed. The shock would ripple through generations, the discovery of a second presence beneath their own fragile shelters. Every philosophy would shift, as existence itself was no longer solitary but shared. The lesson would echo, life finds ways, even in exile. Even their technologies for travel would evolve, perhaps crafting ships to swim oceans before they attempt the void. The transition from water to space would feel natural because both demand sealed environments, pressure, and patience. Every innovation reflects continuity, from maintaining habitats to building vessels that could endure longer journeys. The steps forward would feel steady, shaped by endurance rather than conquest. Picture one day when a vessel finally leaves their planet, bound not for survival, but for exploration itself. The moment would be monumental as fragile beings of ice-born culture reach outward for the first time. Every observer would watch their trajectory, a line across darkness that proves curiosity is stronger than fear. The meaning is cosmic. Exile does not limit wonder, it intensifies it. Even without suns, rogue planets become schools, teaching that life adapts, creates, and questions endlessly. The harshness of their environment breeds wisdom, forcing patience, humility, and perseverance. Every generation learns not to waste, not to assume, but to test carefully and value survival. The truth becomes clear. Difficulty does not diminish progress, it deepens it. Imagine how contact with others might unfold when explorers from Earth or elsewhere finally arrive. The differences would astonish. Myths without suns, civilizations without seasons, knowledge without horizons. Every shared word would reshape our view, teaching us that our assumptions were narrow. The exchange would echo across both worlds, across both minds. Think of what such people could teach us about identity, forged not by stars, but by silence. The stories they carry would emphasize endurance, cooperation, and meaning found in small rituals. Every gesture of theirs would remind us that civilization is not about expansion, but about balance. The wisdom would humble us, showing that survival itself can be greatness. Even loneliness here transforms into a teacher, shaping thought with patience, with stillness, with depth. The emptiness outside becomes an invitation to reflect inward, not an obstacle to avoid. Every pause of silence is a chance to hear self, to measure life differently. The gift of exile is paradoxical. Isolation that builds connection to the universe. Imagine, again, the endless drift of their world, carried without purpose, without destination, yet still alive. The planet itself becomes a symbol, a wanderer, proving that roots are not required for endurance. Every orbitless body carries its history, scars of violence, but also patience of survival. The reminder stays with us. Belonging is not always tied to place. Even our own species may one day share this path, drifting on worlds or ships through interstellar dark. The future may hold generations who never see a sun, yet still carry culture, memory, and hope. Every story we tell now prepares us for such possibility, for exile as natural evolution. The thought lingers. We too may learn to thrive in silence. Standing on a rogue planet would be unlike anything we know, every sense forced to adjust to an environment stripped of starlight. The surface would be coated in ice kilometers thick, shielding possible oceans below, while the land above remains frozen beyond human endurance. Temperatures would plunge toward extremes measured in hundreds of degrees below zero, with even nitrogen and oxygen locked as solids. The landscape would appear timeless, a frozen crust unchanged for billions of years. Imagine yourself walking across this surface, boots sinking into layers of frost, where no wind shapes dunes and no sun melts snow. The air would be thin or absent, offering no breathable mixture, only choking cold gases clinging faintly to gravity. Without sunlight, there would be no skies painted with blue, only endless blackness filled by sharp, unfiltered stars. The experience would be alien, yet breathtaking in its stark beauty. Every step across this world would sound hollow, your own movements amplified in the silence, echoing far across frozen plains. The crust might crack beneath weight, revealing hints of buried layers, scars left from ancient collisions or eruptions. Occasionally, faint geothermal heat might soften patches of ice, bubbling up through vents that still carry inner warmth. The contrast would be striking. Frozen silence beside rare islands of hidden activity. Rogue planets retain heat for eons, their cores slowly leaking energy into surrounding layers, much like Earth does beneath its crust. The radioactive decay of elements continues producing warmth, enough to sustain oceans beneath kilometers of protective ice. Some models suggest these subsurface seas may last billions of years, insulated perfectly against the cold of space. The idea is profound. Habitability without a sun is possible. Beneath that ice lies the most promising environment, dark oceans stretching farther than any on Earth. Rich with mineral chemistry, the geothermal vents here would mimic hydrothermal systems on our planet, where life thrives without sunlight. On Earth, bacteria feed on sulfur, iron, and methane, supporting entire ecosystems of worms, crabs, and deep-sea fish. The parallel is compelling, suggesting that rogue planets may shelter life in similar ways. Surface exploration would reveal only silence, yet the oceans below could teem with chemistry that fuels biology. The conditions echo Europa and Enceladus, icy moons with potential seas hidden beneath crusts of frozen water. Studying rogue planets allows us to test theories of habitability far beyond traditional zones near stars. The truth grows clearer. Life may hide where we least expect it. Standing outside, the view of the sky would be unforgettable, galaxies and stars appearing brighter than ever, unfiltered by atmosphere. The Milky Way would blaze in incredible clarity, every spiral arm stretched across the black with precision. Even faint nebulae would glow more clearly than on Earth, their light no longer dulled by scattered air. The cosmos becomes your sky, a constant reminder of exile. Time would feel distorted here, without sunrises or seasons to mark passage. The body relies on cycles of light and dark, but rogue planets offer only permanent night. Civilizations would require artificial lamps, strict clocks, and carefully designed routines to preserve sanity. The flow of life becomes circular, detached from nature's markers. Gravity would vary depending on the size of each world, some planets as massive as Jupiter, others smaller than Mars. The pull would determine whether thick atmospheres cling close or if gases escape into space. On massive bodies, hydrogen and methane may linger, forming deep blankets that trap heat for eons. The effect would stabilize conditions, creating warmer seas than expected. Smaller rogue planets might lose atmospheres entirely, leaving bare surfaces exposed to cosmic radiation, frozen and silent. The contrast between massive and small rogues defines their potential for habitability. Each type teaches us different lessons about resilience, adaptation, and how environments evolve without suns. The spectrum of rogue planets is wide, from barren stones to hidden ocean worlds. Detection of these worlds is extraordinarily difficult since they emit no light of their own, only faint heat signatures. The infrared glow of residual warmth is the primary clue astronomers seek with sensitive telescopes. Gravitational microlensing is another tool, when a rogue planet's gravity bends starlight as it drifts past our view. The method is precise, but events are rare and fleeting. Scientists have already detected several candidates, each detection brief but convincing, pointing toward billions of rogues across the galaxy. The numbers suggest they may outnumber stars themselves, hidden worlds drifting between systems. Every galaxy may be filled with orphaned planets, remnants of violent births or gravitational chaos. The scale is humbling. Silence does not mean absence. Imagine storms on such planets if atmospheres remain thick enough, swirling endlessly without the push of sunlight. The winds could circulate for centuries, driven by inner heat and planetary rotation. Without a star, storms would never weaken by seasons, locked instead in permanent patterns. The climate would feel alien. Eternal storms in an eternal night. Magnetic fields may still exist if cores remain active, shielding planets from cosmic radiation. The presence of such fields could protect life below ice, preserving fragile biology from destruction. Even if atmospheres thin, magnetic shields would matter for long-term survival. The lesson persists. Unseen forces can shape entire destinies. Explorers from Earth would face immense challenges here, building habitats in environments harsher than Mars or icy moons. The energy demands would be staggering, reactors and geothermal sources required to maintain life. Every expedition would depend on closed systems from food to air, leaving no room for error. The effort would be daunting, but human curiosity is relentless. Picture drilling through kilometers of ice, deploying submarines into oceans that have never known light. The pressure would be crushing, far beyond anything our deepest submarines withstand. Still, the reward could be extraordinary, discovering ecosystems unlike any seen before. The possibility drives us forward, because discovery is worth the risk. Future technology may allow probes to travel directly to rogue planets, seeking evidence of oceans, atmospheres, and biology. The missions would take decades, requiring patience beyond current programs. Yet, the potential discoveries could transform science, proving life exists without stars. The dream endures, humanity reaching for answers in silence. Even lifeless rogue planets have value, preserving early records of formation, unaltered by starlight. The minerals locked within carry histories of collisions, migrations, and ancient cosmic events. Studying them would expand knowledge of planetary evolution, giving context to our own solar system. The archive is invaluable, exile as a record rather than a curse. Imagine civilizations forming here, adapting fully to rogue conditions. Their science built upon darkness, not light. The tools they craft would measure radiation, pressure, and chemistry, rather than orbits and seasons. Every experiment would echo ours, but reshaped by unique needs. The perspective would remind us, intelligence is not bound to starlight. Even our perspective shifts when we think of rogue planets, no longer as wastelands but as hidden reservoirs. The concept of a habitable zone changes, showing life may thrive where we thought impossible. Every step in research expands horizons, widening our view of what possible means. Reflection carried us through the last part, reminding us that philosophy grows even in exile. Yet the science itself remains waiting for us to explore. The truth is that beyond meaning and identity, rogue planets are also physical worlds with landscapes, atmospheres, and conditions we can imagine. Every idea of belonging must eventually meet the harder facts. the surfaces and environments that define these drifting orphans of the galaxy. The time has come to stand upon them, to ask what we would feel, see, and measure in their silence. Imagine stepping onto such a surface, the crust beneath your boots harder than Antarctic glaciers, frozen solid for billions of unbroken years. The temperature falls to unimaginable depths, hundreds of degrees below freezing, locking even gases into solids that cling faintly in thin atmospheres. Here, there are no sunrises, no familiar warmth, only endless night with stars painted sharply across the sky. The scene is stark. A frozen planet drifting quietly, indifferent to our presence. Every sound you make echoes strangely, carried through thin air that cannot soften footsteps. Your breathing amplified by silence more absolute than Earth's deserts. The ice stretches unbroken to every horizon, a barren sheet with cracks carved by tectonic stress and ancient collisions. Occasionally, faint geothermal heat rises through vents, melting pockets beneath the frozen shell, evidence of lingering energy inside the core. The contrast is extraordinary. Stillness above masking hidden movement below. Rogue planets preserve heat for billions of years, their cores slowly leaking radioactive energy, enough to sustain entire oceans beneath kilometers of insulating ice. The ocean, locked below, could dwarf Earth's, stretching farther than any sea we know, liquid despite the cold. Geothermal vents in these oceans would create chemical gradients, feeding microbial life much like Earth's deep-sea ecosystems. The parallel is striking. Sunlight is not the only path for biology. On Earth, extremophiles live in boiling vents, frozen glaciers, acidic lakes, and radioactive waste, proving life adapts wherever energy persists. The existence of these organisms makes rogue oceans plausible, potential homes for creatures thriving without a sun. Bacteria would convert chemicals to energy, forming the foundation of alien food webs under ice. The lesson echoes clearly. Life requires persistence more than familiarity. Above those oceans, the surface remains brutally harsh, a place where unprotected life cannot endure. The environment stripped of air, warmth, and movement. The atmosphere, if present at all, would likely be thin hydrogen or methane, clinging to massive rogues and preserving trapped heat. Smaller planets might lose atmospheres entirely, leaving bare rock exposed to radiation and cosmic dust. The range of conditions is vast, from barren stones to cloaked giants. Gravity on these worlds would vary dramatically, depending on mass and size, shaping everything from surface pressure to ability to hold gases. The giants, as large as Jupiter, may keep thick blankets of hydrogen and helium around them. Smaller Earth-sized rogues would have weaker pulls, allowing atmospheres to drift away slowly into interstellar dark. The difference determines habitability, whether oceans stay liquid or freeze forever. Standing on a massive rogue giant would feel impossible, its surface buried under crushing pressure, an endless sea of gas above dense cores. The clouds here would swirl eternally, storms lasting centuries, powered not by sunlight but by interior heat. Imagine a storm without seasons, a hurricane that never weakens because no star drives cycles to calm it. The climate becomes alien, perpetual motion in permanent night. Smaller rogues, rocky and icy, offer clearer surfaces to walk upon, though each step feels heavier or lighter depending on gravity. The experience would challenge human physiology as muscles adapt to pulls unlike Earth's familiar tug. Even small differences in weight alter how bodies age, how bones carry stress, how blood circulates. The effect of gravity is profound, shaping daily life more than silence itself. Magnetic fields may still protect these worlds if cores remain molten and conductive, shielding oceans below from radiation. The presence of such fields matters for long-term life, preserving fragile biology from cosmic harm. Without protection, particles streaming through space would damage molecules, hindering survival on any exposed layer. The shield of magnetism becomes salvation, invisible yet essential. Imagine the sky above, darker than any seen on Earth, filled with billions of points shining unfiltered by atmosphere. The Milky Way would blaze with piercing clarity, its arms stretched vividly across the black. Every galaxy cluster would reveal itself, luminous and sharp, undimmed by haze or clouds. The sight would overwhelm, the universe becoming your only sky. Time loses structure here. No sun to divide days or seasons, only mechanical clocks or cycles invented by civilization. The rhythm of life must be engineered, artificial light standing in for dawns and dusks. Every routine would be created, not gifted by nature, tying survival to invention. The flow of existence becomes circular, unanchored from starlight. Detection of rogue planets is extraordinarily difficult, since they emit no light, only faint infrared from residual heat. The infrared glow leaks slowly, detectable only with powerful telescopes tuned for such faint signatures. Another method, microlensing, captures moments when rogue gravity bends starlight passing behind them. The events are rare, but they prove hidden worlds exist. Scientists estimate these planets may outnumber stars, billions wandering between galaxies, silent yet common. The calculations suggest each system ejects members regularly, flinging smaller planets outward. Over cosmic timescales, galaxies become crowded with free-floating orphans. The scale is staggering. The dark is full of unseen companions. Imagine storms on atmospheric rogues driven only by heat within, swirling for centuries in endless loops. The winds would never stop, never weaken, for seasons no longer exist to disrupt them. On gas giants, lightning would crackle across methane clouds, illuminating darkness for brief seconds. The effect would be mesmerizing. Power without pause. Smaller, icy rogues would show craters and faults, frozen wounds from ejection and collisions. The surface tells a history, each scar a record of violent beginnings. Studying them reveals instability, migration, and cosmic chaos. The planet itself is an archive, exile preserving memory. Explorers might one day reach these worlds, sending probes across light years, drilling through ice to test oceans. The missions would stretch decades, requiring patience and endurance. Yet, the discoveries could redefine habitability, proving life endures without stars. The possibility pulls us forward, imagination becoming drive. Even lifeless rogues matter for science, preserving ancient materials. Minerals that record the earliest collisions. The study of these bodies would show how systems collapse. Every orphan planet expands knowledge of planetary evolution, broadening the context of our solar system. The value of exile grows. Silence carries lessons too. Imagine civilizations here, crafting their own technologies to explore seas beneath ice, building probes to reach deeper. The tools they design may mirror ours, shaped by need rather than luxury. Every innovation reflects adaptation, resilience, and curiosity. The message is universal. Intelligence flourishes even in shadow. Even Earth's view shifts as we ponder these worlds, no longer dismissing them as empty, but as potential homes. The concept of habitability broadens to oceans under ice, powered by geothermal heat. Every discovery here widens hope that life is not rare. The cosmos grows generous. Possibility stretches across the dark. Picture standing again on the frozen surface, galaxies sharper than memory, silence deeper than thought, knowing oceans stir beneath. The air may be thin, the temperature merciless, yet the presence of hidden water gives meaning. Every crack in ice suggests unseen depths, mysteries waiting beyond sight. The feeling is undeniable. Exile is not emptiness, it is potential. After imagining the feel of standing on rogue planets, the question arises naturally: how can we actually confirm such worlds exist beyond our thoughts? The challenge is immense, for these planets shine with no light of their own, blending invisibly into interstellar night. Yet, astronomers have devised clever ways to capture their faint signatures, using physics itself as a guide across impossible distances. The methods reveal hidden wanderers, one fleeting glimpse at a time. Microlensing is one of the most powerful techniques, a phenomenon predicted by Einstein where gravity bends light, acting like a cosmic magnifying glass. The idea is simple in concept, but rare in practice. A rogue planet passes exactly in front of a distant star. Gravity from the planet bends the starlight, creating a brief brightening, a temporary lens revealing an otherwise invisible object. The effect lasts only days, but it confirms the presence of a hidden world. Every successful microlensing event is celebrated intensely, for they cannot be repeated. The rogue planet continues drifting on its endless path. The data collected allows scientists to estimate mass, distance, and sometimes even possible companions. Though the glimpses are brief, the evidence accumulates, building a statistical case for billions of unseen planets. The truth is sobering. The galaxy is more crowded with orphans than stars. Infrared observations provide another pathway, catching the faint heat still leaking from planetary interiors, even long after stars were left behind. The radiation is weak, requiring the most sensitive telescopes like Spitzer or the upcoming James Webb. Even then, only the closest rogues can be seen directly, their glow dimming quickly across cosmic scales. The difficulty reminds us exile is invisible by design. Surveys across wide fields of sky have revealed dozens of candidates, each one a hint of a much larger population. The findings suggest that for every star, there may be several free-floating planets ejected during early formation. Models of planetary dynamics support this, showing how gravity slingshots smaller worlds into interstellar space. The numbers are staggering. Hundreds of billions of wanderers may drift in the Milky Way alone. Some rogue planets detected are massive, close to Jupiter's size, their bulk easier to catch with microlensing or infrared glow. The giants are not habitable in familiar ways, but their moons could still shelter potential life. Others appear Earth-sized, small enough to freeze quickly, yet possibly holding oceans beneath protective crusts. The diversity is remarkable. Exile does not follow one path. Consider a discovery from the early 2010s, where surveys found several objects too massive to be brown dwarfs, yet too light to be stars. The instruments revealed these were planetary mass bodies, wandering alone without stellar anchors. Though distances remain uncertain, the confirmation proved such planets exist and can be counted scientifically. The moment was historic. Theory became tangible. Later studies revealed candidates within a few thousand light-years, astonishingly close on galactic scales. The reality that rogue planets exist within our neighborhood deepens the wonder, reminding us how much still hides nearby. Each detection refines our models, allowing predictions of how often such bodies are created. The evidence becomes stronger. Exile is common, not rare. Even when unconfirmed, these faint signals matter, for they test the sensitivity of telescopes and the patience of scientists. The search requires watching millions of stars, waiting for the smallest changes in brightness. Sometimes, a planet as small as Earth reveals itself through microlensing, lasting only hours before fading again. The discipline demanded is extraordinary. Astronomy becomes an act of faith in data. Future missions aim to expand these searches, with projects like the Nancy Grace Roman telescope, designed specifically for microlensing. The survey will observe dense star fields near the galactic bulge, where alignments are most common. Every event detected could reveal planets untethered to stars, helping to count the orphans of the galaxy. The prospects are thrilling. Billions may be confirmed within decades. James Webb adds another tool. Its infrared vision, sharper than anything before, capable of catching faint thermal signatures. The possibility of directly observing rogue planets grows, though only the warmest and nearest are visible. Still, this marks progress, showing that detection no longer relies solely on chance microlensing. The path forward expands, exile becomes visible. Even ground-based observatories contribute, with massive arrays scanning constantly for fleeting signals. The cooperation of instruments worldwide allows confirmation of rare events, ensuring no candidate is missed. Every successful detection strengthens confidence, showing that our models align with reality. The achievement is quiet but profound, discovery in silence. Imagine being an astronomer watching a light curve, the graph of a star's brightness, waiting for the smallest dip. The moment comes suddenly, a rise or fall that betrays a lensing event. Data floods in, telescopes redirect, and confirmation begins. The feeling is electric. Exile is glimpsed across light years. Scientists analyze these curves with careful mathematics, extracting mass estimates and possible orbital histories. The results are often uncertain, but even ranges reveal patterns. Some rogues may be single bodies, others may still hold faint moons. The details are sparse, yet they build toward truth. Over time, a clearer picture forms. Rogue planets are not rare exceptions, but products of planetary evolution, inevitable outcomes of crowded systems. The early solar system may have ejected its own members, flung outward during violent migrations of Jupiter and Saturn. Simulations suggest Earth itself nearly faced such a fate, destabilized by gravitational chaos. The fact humbles us. Exile could have been ours. Thus, the search is also personal, teaching us that stability is fragile, survival not guaranteed by birth. The planets we live upon remain secure only because of lucky balances, configurations that protect Earth's path. Others were less fortunate, cast into the dark, yet still enduring. The galaxy reminds us, chance shapes destiny. Imagine probes one day reaching nearby rogue planets, instruments measuring crusts, oceans, and atmospheres directly. The journeys would be long, decades across interstellar space. Still, their findings could change our definition of habitable, proving life may exist beyond starlight. The dream of discovery persists, carried by curiosity. Even without direct probes, the next century promises enormous progress. Billions of candidates catalogued statistically. The census of orphaned planets will reshape how we think of galaxies, expanding their invisible populations. Every star may be only one piece of a larger puzzle, surrounded by companions hidden in the dark. The vision is humbling, abundance hidden in darkness. Among the earliest candidates confirmed through microlensing was a planet only a few times larger than Earth, drifting quietly without a parent star to warm it. The discovery was fleeting, a brief lensing event recorded as starlight brightened unexpectedly before returning to normal. Scientists realized they had just glimpsed a lonely world, unseen before and never to be aligned again in the same way. The evidence proved that rogue planets were not imagination but measurable parts of reality. Later surveys toward the center of the galaxy revealed entire populations, dozens of microlensing events that could only be explained by free-floating planets. The statistics were compelling, suggesting hundreds of billions of unseen orphans scattered through the Milky Way. Though none of these worlds could be studied in depth, their existence was undeniable, shaping new theories of planetary formation. The numbers painted a cosmos where exile is normal, not rare. One famous candidate is known as Ogle 2016 BLG 1928, a planet detected through microlensing that appeared smaller than Earth. The signal was astonishingly short, lasting less than 40 minutes before fading, a glimpse of something fragile in the dark. Such brevity meant only a tiny planet could cause it, proof that even Earth-sized rogues wander alone between stars. The lesson was simple: exile applies to giants and to the small alike. Another striking detection was PSO J31T.522, a free-floating planet found in 2013, about 80 light-years from Earth. The object was massive, nearly the size of Jupiter, but glowing faintly in infrared as it still radiated heat from formation. Unlike most rogues seen through lensing, this one could be observed directly, allowing astronomers to study its spectrum. The finding was monumental. Exile had become something visible, not only statistical. PSO J31T.522 belongs to a young stellar group. A moving cluster of stars formed together about 12 million years ago. The membership confirmed its youth, meaning it was still warm enough to glow without a star. Spectroscopy revealed clouds of dust and methane, features common to gas giants, but here adrift without orbit. The portrait was haunting, a glowing world adrift in silence. Other similar finds include YZA J1147-2040 and SIMP J0136+0933. Planetary mass objects straddling the line between planet and brown dwarf. The distinction blurs in exile, for without stars, classification depends entirely on mass and composition. Still, they represent rogue worlds, floating freely, glowing faintly in infrared like embers scattered across the void. The catalogue of such objects continues to grow steadily with each survey. Even younger clusters like Upper Scorpius reveal free-floating planets, dozens of them scattered within associations only a few million years old. The youth makes them easier to spot, their residual heat still bright enough for infrared telescopes. Older planets fade completely into darkness, invisible except when gravity betrays them during rare alignments. The contrast reveals a life cycle, brightness fading into silence. Consider, again, PSO J318.522, sometimes called a rogue Jupiter. Its faint glow studied carefully by adaptive optics on large telescopes. The observations revealed variability, storms and weather patterns even without sunlight to drive them. Clouds of silicates and iron drift across its atmosphere, proving that rogue planets are not static but dynamic worlds. The conclusion is powerful: exile does not erase complexity. Some rogues may even hold moons, companions captured before ejection or retained during violent scattering. The possibility excites astronomers, for such moons could hold conditions stable enough for life beneath ice. Imagine a giant rogue world with a captured moon, tidal heating stirring oceans even without starlight. The prospect changes everything. Habitability extends far beyond stars. Models of planet formation suggest that ejection is inevitable. During the chaotic youth of planetary systems, the giants, like Jupiter, migrate inward or outward, destabilizing smaller neighbors with gravity. Many of those smaller planets are flung outward, escaping their system entirely to drift alone. The mechanism explains abundance. Exile is a natural outcome of creation. Evidence also suggests that even our solar system once lost members, worlds that formed alongside Earth but were later ejected. The traces remain only in simulations, mathematical reconstructions of planetary migration. Had Earth's path shifted slightly, our own planet could have been among them, cast into silence forever. The thought is sobering, existence is precarious. Even giant ejections leave trails, comets and debris marking instability in planetary birth. The patterns of rogue planet frequency align with predictions, validating these violent scenarios. Each confirmed rogue adds weight to planetary dynamics, strengthening our understanding of how systems evolve. The cosmos reveals itself slowly, but with consistency. Imagine the loneliness of PSO J318.522, glowing faintly with no sun, its nights eternal, its clouds unlit. The view from its atmosphere would show endless stars, brighter than on Earth, because no nearby light pollutes the sky. Every rotation would pass in unchanging darkness. No dawn, no dusk, only storms rolling endlessly. The picture is haunting, exile feels infinite. Yet, such loneliness does not mean emptiness, for chemistry continues, weather shifts, clouds evolve. The planet may not support life as we know it, but its dynamics teach us resilience. Even without a star, energy remains. Heat radiates, particles move, and atmospheres churn. The lesson is firm: exile is still alive with motion. Consider again the fleeting event of Ogle 2016 BLG 1928, a planet smaller than Earth caught only briefly. The duration of 40 minutes was so short, astronomers nearly missed it. Such discoveries remind us how fragile evidence can be, here and gone within an evening. The patience required to find them is extraordinary. Other candidates include massive free floaters near the galactic bulge, where microlensing is most often observed. The crowding of stars increases chances, making alignments more common. Dozens of such events have now been linked to rogue planets, building a statistical census. The picture grows richer. Abundance is confirmed by numbers. Meanwhile, infrared surveys such as WISE have scanned for heat, catching faint signatures of young rogues still glowing. The catalogue now includes dozens of planetary mass objects, their temperatures measured, their motions tracked. Each one confirms that wandering is not exceptional, but part of planetary evolution. The pattern grows undeniable. Exile is cosmic norm. Imagine future telescopes mapping thousands of these planets, each one with a story of violent birth. The statistics will reshape our vision, no longer star systems alone, but starless worlds too. Every detection will expand the known galaxy, adding silent wanderers to its architecture. The shift in perception will be profound. Even artists inspired by science create visuals, depictions of glowing giants adrift, of frozen Earths without skies. The illustrations spread across media, igniting imagination, blending fact and vision. Though these images are art, they carry truth, reminders of discoveries shaping our era. The impact is cultural. Exile enters our myths again. Scientists continue refining methods, sharpening models, and preparing for Roman and Webb to expand the catalogue. The expectation is that thousands more rogues will be found, confirming their abundance. Each detection strengthens the case, reshaping how galaxies are imagined. The future of astronomy points toward dark abundance. Imagine teaching children one day that for every star, there are many more planets wandering in exile. The shift in perspective will shape philosophy, redefining place and belonging. Every story of worlds will include the exiled, not just the anchored. The cosmos will feel larger, stranger, and richer. Already our own solar system is suspect. Jupiter's migrations may have ejected planets billions of years ago. The absence leaves questions about histories, paths lost to the void. Even today, models suggest more candidates could drift nearby. Unseen except through rare alignment, the mystery remains open, waiting for detection. Having glimpsed these hidden wanderers through data, the natural question becomes, how might we one day touch them with our instruments? The dream of exploration is not distant fantasy. It begins with telescopes already being prepared, sharpened to capture faint light across space. Roman will watch the galactic bulge sifting through millions of stars, searching for the brief distortions caused by passing rogue planets. The promise is immense, offering catalogues instead of single events. James Webb adds to this vision, its sensitivity unmatched in the infrared, able to detect the lingering warmth of young rogue planets. The ability to catch atmospheric signals, to sense methane or water vapor, transforms these objects from statistics into characters of cosmic history. Even without visiting directly, Webb's eyes can map climates, revealing whether storms or clouds churn within alien skies. The future of observation grows sharper, building bridges toward touch. Beyond telescopes, the challenge of sending probes arises. Distances of tens or hundreds of light years make direct missions daunting. The journey would span centuries, unless propulsion advances carry us far faster than chemical rockets allow. Concepts like solar sails or fusion drives whispered today as experiments, could become tomorrow's engines. The possibility is there, requiring patience measured in generations. Imagine a probe aimed at PSO J317.522, carrying instruments to study atmosphere, storms, and magnetic fields. The craft would accelerate for decades, then drift silently for centuries before finally breaking into orbit around its destination. Such missions sound impossible with today's limits. Yet history shows ambition often outpaces expectations. The vision of such a journey endures, driving invention forward. Closer rogue planets may exist within a few hundred light-years, detectable soon with more powerful surveys. The targets for probes would then shrink in distance, perhaps requiring only centuries instead of millennia. Every advancement in propulsion reduces that gap, bringing unreachable worlds into plausible plans. The scale remains immense, but not hopeless. Meanwhile, humanity already experiments with endurance. Astronauts aboard the International Space Station live months in isolation. The lessons they gather about psychology, biology, and machines prepare us for survival far from Earth. Submarines on Earth mirror conditions even more closely, confined, self-sustained, and dependent on precise systems. The parallels to rogue planet habitats are striking, practice for futures we cannot yet see. Imagine building domes beneath ice on a nearby rogue planet, habitats powered by geothermal taps or compact reactors. The residents would live without stars, marking time by lights and machines instead of dawn. Every resource would be recycled, every drop of water precious. Cooperation the only guarantee of survival. The existence would be harsh yet achievable. Geothermal power offers a steady path. The same heat that sustains oceans could fuel human lives. The vents would provide warmth and potentially chemistry useful for crops or even oxygen extraction. Engineering solutions exist today in the form of reactors, tested in polar regions or submarines. The technology already hints that survival is within reach. Imagine stepping outside that habitat into frozen silence. The stars sharper than ever, no haze, no atmosphere to blur. The boots crunch against frost. Your visor fogs slightly, your own breath the only movement. Above, galaxies blaze across the black, stretching farther than any earthly night. The beauty is overwhelming, silence becoming spectacle. Even the smallest probe could change our knowledge, instruments drilling ice to confirm hidden oceans. The samples returned, frozen or liquid, would tell stories of chemistry, perhaps of biology. Beneath kilometers of crust, ecosystems might wait, shielded and preserved for billions of years. The discovery would redefine life's boundaries instantly. Consider the implications of finding microbes under rogue ice, life that never saw a star. The impact would ripple through science, showing that biology is not tied to starlight. Every assumption about habitability would shift. Earth no longer the model, but only one variation. The universe would appear friendlier, richer in survival. Imagine, further still, advanced civilizations thriving beneath ice, hidden so well we cannot detect them. The concept unsettles yet excites, suggesting intelligence could evolve without stars, never sending signals outward. Instead of skyward curiosity, their focus would remain inward, on oceans, currents, chemistry, and endurance. The possibility reminds us absence of evidence is not evidence of absence. Meanwhile, we must refine detection methods, improving sensitivity, extending telescope lifetimes, sharpening software to sift data. The Roman telescope is central, scanning thousands of stars at once, capturing lensing events by the dozens. Each event reveals mass and distance, adding to catalogues with precision. The result will be a census, a map of exile. Ground observatories support this effort, synchronized to confirm faint alignments before they vanish. The teamwork of global instruments creates confidence. One telescope's noise becomes another's signal. Patience is everything. Waiting years for alignment, sometimes decades. The reward is profound. One fleeting signal expands knowledge. Imagine the first time an ocean is confirmed under rogue ice. Billions of cubic kilometers of liquid water. The confirmation would ignite questions. What organisms might lurk? What chemistry sustains them? Drills would pierce carefully, instruments lowered into depths, searching for amino acids, for cells, for patterns of life. The moment would echo Apollo, one small step reshaping perspective. Even without life, rogue planets preserve planetary histories. Fossils of formation frozen in exile. The cores hold records of migration, ejection, and collisions. Stories carved into composition. Studying them reveals the early chaos, how systems fling away children during violent beginnings. The lessons enrich cosmology, deepening origins. Consider the psychology of explorers landing there. No sunrise, no sunset, no shifting shadows. The mind adapts poorly without cues. Depression and disorientation pressing close. Artificial cycles would guide sleep, lamps rising and dimming by command. The challenge would be profound, as much mental as physical. Yet humans are resilient. Explorers endure isolation in deserts, poles, and oceans. The examples show adaptability, a trait as essential as any technology. Every rogue planet colony would test this resilience, generations measuring strength against silence. The result would be cultures defined by endurance. Imagine art created by such colonists. Not constellations, but glowing murals of vents, oceans, machines. The music would echo in closed halls, low tones, metallic beats mirroring machinery. Even silence could become art. Pauses extended, rhythms slowed, reflecting the frozen environment. The culture would be shaped uniquely, belonging to exile. Meanwhile, science would advance relentlessly, each colony a laboratory studying isolation, oceans, and physics. The findings would extend to Earth, teaching medicine, biology, psychology, and engineering. Even failure would enrich knowledge, each attempt recorded, each hardship instructive. The pursuit itself is valuable, knowledge born from challenge. Consider the deeper significance, that rogue planets expand the definition of home. The cosmos is not just suns with systems. It includes wanderers, silent yet enduring. Every discovery stretches identity. Humans seeing themselves in solitude as much as in company. The truth is that belonging is wider than we thought. Imagine the day a probe sends back images from a rogue surface, frost stretching endlessly beneath stars. The transmission would thrill humanity. The first clear portrait of exile. Every detail would matter. The crunch of ice, the glow of auroras, the blackness unbroken. The moment would echo across history, exile seen directly. Even further, human settlers might thrive, not just survive, but build culture. The generation born under ice would feel no loss, their normal defined by machines, vents, and silence. Over centuries, they would adapt completely, their myths and values shaped by exile. The species itself would evolve, expanding into darkness. Standing on a rogue planet is unlike anything we can imagine on Earth, because the surface offers no warmth, no dawn, only frozen silence. The sky above is sharper than any telescope view, countless stars piercing the black without atmosphere to blur their edges. Every step you take presses into brittle ice, your own weight echoing outward across plains undisturbed for millions of years. The feeling is overwhelming, a calm that is vast, deep, and absolute. Breath fogs instantly before you, curling into drifting crystals that vanish just as quickly, a reminder that the air cannot sustain life. The cold presses down relentlessly, so deep it feels more like absence than temperature, as though warmth has never belonged here. Touching the crust through a heavy glove, you sense solid stone beneath, harder than Antarctic glaciers, untouched by weather or erosion. The truth is stark. This is a world where time itself seems motionless. Above, faint moons may circle their parent body, steady in silent orbits. Companions moving patiently even without a star to anchor them. The motion is slow, yet unbroken, their pale disks gliding through the dark skies, reflecting starlight too faint to give warmth. Every orbit is like a clock hand, marking cycles that pass without seasons, without sunrise or sunset to measure them. The awareness of this stretches your imagination, forcing you to think of time in new ways. Imagine kneeling down, pressing your hand against the thick ice, knowing beneath lies a vast ocean warmed by hidden geothermal heat. The seas may stretch deeper than Earth's Mariana Trench, kilometers upon kilometers of dark water sealed away from space above. Creatures could thrive here without light, using chemical energy to survive, much like microbes and vent animals in Earth's oceans. The possibility changes everything, showing that life can emerge even without stars. Here on Earth, we already know of extremophiles, organisms that survive in boiling vents, acidic pools, and frozen glaciers. The existence of these beings proves that biology is not fragile but resilient, stretching to occupy niches where survival seems impossible. By studying them, we understand that life may not require sunlight at all, only energy from rocks, chemistry, and water. The lesson is humbling. Survival adapts to places we once believed sterile. Standing beneath this sharp galaxy sky, you notice how bright the Milky Way appears. Its spirals glowing without the haze of air. The stars blaze in impossible numbers, every faint cluster visible, painting the black canvas with clarity Earth's atmosphere denies us. Every faint galaxy shines as a soft cloud, stretching far beyond what human eyes evolved to perceive from home. The view is haunting, infinite, and strangely peaceful. Time itself loses meaning on a rogue planet, because there is no daylight to divide hours, no sunrise or sunset to guide lives. The concept of days and months would fade quickly, replaced by clocks, machines, or artificial cycles built by necessity. Civilizations here would measure time by mechanical pulses, by breathing rhythms, by the repetition of tasks that sustain survival. The flow would feel dreamlike, detached from everything familiar. Now, How do astronomers on Earth even find these wandering worlds when they reflect no sunlight and drift invisibly through space? The answer lies in subtle methods, careful observations that reveal their presence indirectly rather than by direct sight. One way is through gravitational microlensing, when a rogue planet passes between us and a distant star, briefly bending and magnifying its light. The effect lasts only days or weeks, but it betrays the unseen planet's mass and presence. Microlensing is powerful because it does not depend on the planet's light. It works even for dark, frozen worlds. The star's brightness shifts slightly, a momentary signature that astronomers capture using networks of telescopes spread across Earth. Every time such an event occurs, we glimpse another wanderer, silent proof that the galaxy teems with hidden planets. The universe reveals itself in fleeting alignments, never twice the same. Another way to detect rogue planets is through infrared, the faint warmth they still release long after being ejected. The radiation is dim, but sensitive telescopes can catch the subtle glow of heat escaping into the dark. Especially younger rogue planets, still cooling, emit enough energy to betray their otherwise invisible existence. The search is difficult, but every detection expands our map of possibilities. Recently, surveys like OGLE and MOA have tracked microlensing events, identifying candidate rogue planets from their temporary distortions of starlight. The data shows that such worlds may outnumber stars, making them one of the most common objects in the galaxy. Imagine the scale of that. Billions of planets drifting alone, each with its own history of birth and exile. The thought changes how we view the cosmos, not as empty but crowded with orphans. Even future missions may advance the search further, with telescopes like Roman designed to catch lensing events at higher precision. The goal is to build a statistical map, showing not just their existence, but how common different sizes may be. Some could be as large as Jupiter, others small as Mars, torn away in the violence of their early systems. The evidence will tell us whether exile is exception or rule. Standing again in imagination on one of these worlds, you begin to picture how silence itself shapes awareness. The ground beneath you is ancient, a frozen record of impacts and scars from collisions that flung it outward. Every crater speaks of chaos, the moments when gravity's grip was lost and wandering began. The landscape is a frozen memory, unchanged by weather for eons. Consider the atmosphere such planets might retain. Thick layers of hydrogen or methane trapping heat like blankets against the void. The effect could maintain liquid oceans for billions of years, sustained beneath kilometers of shielding ice. Such an atmosphere would make the surface crushing, with pressures higher than Earth's deepest oceans. The environment would be hostile, yet strangely supportive of hidden stability. Imagine civilizations venturing here in the far future, building habitats beneath protective ice. The settlers would anchor domes and tunnels, warmed by nuclear power or the heat of geothermal vents. Every life support system would recycle air and water, with machines replacing the role of seasons. The survival would be possible, though it would test ingenuity endlessly. Still, even without life or civilization, rogue planets hold immense value, preserving ancient records of planetary formation. The cores of these worlds contain clues about collisions, migrations, and the dynamics of their lost systems. Studying them would reveal how common instability is, how often planets are cast adrift during the birth of stars. The knowledge would reshape our models of galactic evolution. Meanwhile, in the quiet of imagination, you return to that surface, boots sinking slightly into frozen powder. The air is absent, yet your breathing fills the helmet with rhythm, reminding you that you are alive. Every star above becomes sharper, their light clean and eternal against the unbroken black. The silence itself becomes your companion, patient, vast, and strangely kind. Think now of the numbers, of billions of wanderers drifting unseen, of how they make the universe fuller than we thought. The idea that most planets are starless orphans is both unsettling and comforting. Comforting because it shows abundance, unsettling because it redefines how we imagine habitability. The truth reminds us exile is not absence. Even here on Earth, we train our telescopes to watch patiently, waiting for light curves to shift, for the briefest signal. The cosmos whispers rarely, but when it does, we learn to hear. Every recorded blip is another planet added to our maps, a body we will never see directly. The evidence builds, slow but unstoppable. Rogue planets remind us that belonging is not necessary for survival, that gravity can cast bodies outward yet not erase them. The stories they tell are about resilience, about finding equilibrium even in darkness. Every frozen crust, every hidden ocean, carries its own truth about endurance. The cosmos teaches through silence, and silence itself becomes profound. Detection of rogue planets remains one of astronomy's most delicate achievements, because they emit little or no light, and their presence must be inferred indirectly. The techniques rely on patience and alignment, on rare moments when a planet drifts between us and a distant star. Gravitational microlensing bends starlight slightly, producing a temporary signal that telescopes can capture if they are watching at the right time. The event is fleeting, but its meaning is permanent. Roman is the telescope designed with this task in mind, its wide field of view capturing millions of stars at once. The goal is to record dozens or even hundreds of events, building a statistical understanding of rogue planets across the galaxy. Every detection tells us about mass, about distance, about the frequency of worlds drifting outside orbits. The data will become our first true census of cosmic wanderers. Infrared astronomy adds another pathway, because even cold worlds retain faint heat for billions of years. The James Webb Space Telescope is sensitive enough to catch these glows, to sense planets invisible in visible light. Especially younger rogue planets, still warm from formation, release detectable radiation that betrays their existence. The method is slow but reliable and already offering promising candidates. Imagine the first confirmed catalogue of hundreds of rogue planets, each one labelled with distance, size, and possible atmosphere. The moment would be profound. A map of invisible wanderers revealed through careful observation. Scientists would trace their origins, studying the mechanisms that fling them free: unstable orbits, collisions, and gravitational encounters. The picture would reshape how we understand planetary systems. From detection, the next dream is visitation, though distances make this a challenge of centuries. The idea of solar sails, of fusion drives, or other advanced propulsion offers glimpses of possibility. Every generation of technology brings us closer to reaching these frozen oceans, closer to drilling beneath their thick crusts. The timeline is vast, but not impossible. Imagine receiving the first images from a probe orbiting a rogue planet, frost stretching endlessly beneath a black, starless sky. The transmission would stun humanity, the first true portrait of exile. Every detail would matter: the cracks in the ice, the patterns etched by billions of years in silence. The moment would echo Apollo, but on a cosmic scale. Drills would follow, piercing the thick crust, searching for hidden oceans where energy still stirs. The samples could reveal amino acids, perhaps simple cells, perhaps chemistry capable of sustaining more. Even negative results would enrich knowledge, proving that life is rarer than we hope, or simply harder to detect. The truth would not diminish wonder, it would expand it. Standing, again in imagination on that frozen surface, you would feel the silence pressing against every sense. The galaxy above would blaze with impossible clarity, its spirals and clusters filling the sky with sharp, unblinking detail. Every star would remind you that home is not confined to one system, not even to one kind of planet. The feeling would be of exile, but also of belonging. Meanwhile, Earth continues its own journey. Telescopes growing sharper, instruments more precise. The scientists designing future surveys already dream of catalogues holding millions of planetary detections. Even if many are bound to stars, a great fraction will be free wanderers. The reality is that exile may be the rule, not the exception. Consider how that changes our perspective. To imagine galaxies filled not only with shining stars, but with countless planets hidden in darkness. The Milky Way may hold more orphan planets than visible suns. Every one of them carries a history, collisions and ejections recorded in their frozen cores. The cosmos is richer, more complex than our early models ever guessed. Even sterile planets remain precious because they preserve early records of planetary systems. The cores hold chemical clues locked away for billions of years. Studying them teaches us how worlds are built and destroyed, how stability is achieved and lost. The archives of exile are waiting to be read. Imagine civilizations that might already exist beneath ice, unseen, undetected, living without stars. The possibility is unsettling, yet it expands our view of life's potential. Perhaps such cultures measure time by currents, by chemistry, by heat, never once looking outward to galaxies. The mystery lingers. We cannot know, but we can dream. Even if life never thrives there, rogue planets still teach resilience. That matter endures even after exile. The lesson is quiet but strong, that existence does not need a central anchor. Every planet continues its path, carrying its own story into the dark. The truth is survival, even in silence. Picture the long future of human exploration, not just stars and bright worlds, but also frozen wanderers. The maps of tomorrow may show both constellations and rogue planets, plotted with equal care. Every probe launched, every signal captured, will expand our understanding of where life might hide. The cosmos becomes less empty with each discovery. Imagine lying back again against frozen ice, your body still, your eyes filled with galaxies unbroken by sunrise. The silence rocks you into calm, the stillness carrying its own rhythm. Every heartbeat feels like a measure of time, soft and unanchored. The moment becomes sleep itself, slow and steady. Thus, we end this long journey, not with answers, but with questions stretched wide across the sky. The rogue planets remain silent, their oceans hidden, their surfaces cold. Yet, they remind us that possibility is larger than stars, larger than anything our early minds believed. The cosmos waits, patient and endless, as we drift with it,